Start recording. Okay, great. Okay, so welcome to research seminar over School of Architecture, and we have I think a fourth speaker today. So we have Professor Madhu Thangavelu. He has been teaching the graduate space exploration architecture concept synthesis studio in the Department of Nautical Engineering within the Viterbi Engineering School. And also he has been teaching the Architecture 599, the Extreme Environment Habitation Design Seminar in the School of Architecture. So at USC, he was mentored by, and also he has mentored many students and working as a research associate in the field of aerospace engineering. And since 1992, he is also a creative consultant to the aerospace industry in the newly evolving field of space architecture, complex concept synthesis. So Mr. Thangavelu concept has been reviewed and appreciated by NASA and National Research Council, National Space Council, and his work has been presented before the National Academy of Sciences. So I know that the National Academy of Sciences is really, really influential organization, and so it must be a really good value for them. And he has presented and published the original concept in space system architecture and chairs related session at conferences. He's a co-author of the book, The Moon Resources, Future Development and Colonization, published in John Willis Sons. And also second book was published in Springers in 2007. So I think his third edition is currently in preparation, and I think we are expecting his third book to be published very soon. Okay, so please join me to welcome Professor Thangavelu.
Thank you. Thank you, Juno. And you know, that bio was written a few years ago, and we are continually writing chapters and books and so on. And but the thing I enjoy most in my work, I must admit, is to talk to the students at the School of Architecture, because every time I engage them, they ground me in the facts and the human predicament, which is happening on planet Earth and not in space. So with that, let me run through some slides and thank you all for coming. So as Juno mentioned, I teach both in the School of Engineering, in the Department of Astronautical Engineering, and not in the Aerospace Engineering Department anymore, because we have a department that is fully dedicated to activities beyond the atmosphere of planet Earth. And we call it astronautics, but graduate school would like to call it astronautical engineering. And I spend some time teaching extreme environments at the School of Architecture. Most of my students are in grad school, but once in a while, a student will appear from a senior division in the undergraduate curriculum, and I welcome their participation, because some of them simply show me that they are beyond their age group or their peer group in thinking about the work. With that, let me continue with some slides. Let me go full screen here.
So so he'll talk for about 45 minutes, and then it will be followed by the Q&A session.
Okay.
So I know that yes, thank you for your patience for the food. Actually, the food is just delivered. So in the during the top, if you some if you need, so yeah, please pick up some.
Well, I think from what Junho told me, you will have plenty of food today because there's not very much of a physical audience there, but enjoy your pizzas. Okay, guys, so let me move on. The first thing I want to mention to you is you're wondering my name. And um, uh, my first name, my last name may sound a little bit different. It is spelled, the last name is spelled Thangavelu, as Mark may mention. But I was very surprised that the first time around, it came with the K on it. And it is interesting in two ways because my background is from the southern part of India. My dad is from Tamil Nadu, or here, and my mom is from Kerala on the west side. And we have some of the world's best beaches right around here. So when I came to LA and I went to Santa Monica Beach, I was wondering where exactly is the beach? So we have different understanding of what beaches should be like and the colors of the water and the sand and so on. Anyway, I thought I'd let you know. So in the western part, they spell my name with a K. And in the eastern part, they spell it with a G. So this is the first time I saw both K and G in the same lettering. But anyway, just a thought. So now some of you are in the group and wondering, what is it that space architects and space folks do, and how it differentiates from what we do as a collective. And it's very clear. Very few people, very, very few, among a fraction of the people on our planet, look towards the skies, asking the deep questions about the cosmos, where we are from and where are we going, what is our purpose, and so on. It is the area of investigation for cosmologists, and astronomers play a role in telling us some trickle down answers to some questions. But the big questions still remain. While most of us, including the well grounded architects, are trying to solve problems with hard solutions for the last few thousand years. And so there is a very big gap in the technologies involved, both looking outwards into space and for us looking deep into the needs of the multitude of the globe's population. So imagine this. The year is 2050. The populations are growing. There are a number of world cities, some of them sprouting now. Energy is an issue, is a very big issue. Food is a growing problem for many people in the world. And yet, we see the wealth of nations increasing, some increasing. There's a lot of pollution and waste in the world. And then, the other side of the equation, people are thinking about building cities on the moon and Mars. And so rather than see it as a contradiction of terms, I like to think of it as the variety of choices that humanity explores and delves in to make our living and our world a um, more interesting place to live in. As I mentioned, where do you think the world population is growing? It's very clear that Africa, India, and China are some of the places where you're going to see rapid growth. So there are some signs, maybe we are approaching some plateau, but still, you will notice compared to the US, where the population is plateaued, or in Europe, you will notice that most of the population growth is happening in these parts here, here, and here. Is my cursor showing, Juno?
Yes.
Yeah, yeah.
Good. Very good. So this is how we expect it to grow. But some of our thinkers, including Elon Musk and so on, think that we may sputter. Our population may peter down, and this is seen in what we called the developed nations, and it's already happening in parts of the world, and we still need more data to understand how that is happening and why that is happening. So this is what it looks like. As I mentioned, it's growing as of now. And the energy consumption is also going up. You've probably heard that most of the energy is consumed by the developed nations, and particularly the United States and Australia, and also parts of Europe, though we don't see too much here, but we know. And the way we know this is through what is happening right now. There is a crunch in the fossil fuel industry, and there is some kind of throttling happening. There's a bottleneck, and we think that this would be um, a call for action. And as you know, right now in Egypt, you have in Egypt is where you have the COP27, the Committee of Parties meeting going on, and I'm following it live. So you will notice that nothing much is happening because of the activities happening in Russia and Ukraine. Now, coming back to fossil fuel use, we also know that um, the uh, the use of energies is somehow correlated with pollution in various nations. And here you see fine particulate matter pollution in the 2.5 micrometer range. That number is important because 2.5 micrometer range is the kind of particulates that can go in through your nose and enter your lungs. And it causes great difficulties in breathing, not to mention it also causes long-term damage to the physiology in terms of pneumoconiosis and other ailments dealing with the lungs. And as you know, last week was extremely difficult for India in New Delhi, and the schools were closed. And this is going on also in China, India, and some parts of Africa. We are spared of it, but some days you will notice here in Los Angeles, when you look up towards the mountains, you will see a layer of smog, which is also part of the 2.5 micrometer range. And then there is the invisible pollution that happens around the world, also associated with industrialization and developments. You will notice that again, China, parts of Europe, and particularly the eastern part of the United States are all implicated in nitrogen oxide emissions, nitric oxide emissions. And these are images that come down to you from satellites in space. And this is why we start to think that looking down on what we do is at least as important as looking around to what you do. So global energy production. Now, we all know that the coal and other fossil fuels, particularly petroleum, are major contributors in the energy production and also emitters of gases and other pollutants that are causing trouble for our life because we all breathe the same atmosphere, depending on not depending on where we live, but as global citizens. So if you look here, you will see that in terms of terawatt hours, how we are using energies, and you will see that coal, gas are all part of the equation. And over time, we are expecting that oil will reduce, and that is we like to think that is happening now. And this is what an image looks like on how fossil fuel has peaked in terms of production. And perhaps the reason why producers want to jack up the prices of a barrel of oil. But it still needs to be seen how the plateau is approached and being reduced over time. But in this image, you can clearly see that clean fuels, finally we have decided to go up and ramp it up. I know these are things that your professor Mark Schiller, who is sitting over there, taught me when I was in school about renewable energies and the wise use of solar power. So many ideas are out about how to use the sun. You know, it's again a paradoxical situation. The sun shines on the earth um, all the time. It just so happens in our physical universe, the way bodies are built, sunlight falls on half the planet and the other half is in the dark all the time. So we have a planet that is spinning. And so we have 12 hours of sunlight wherever the sun is shining and 12 hours of night. We still don't know how to employ that abundant solar energy, uh, a fraction of which can sustain all the developments on planet Earth. Yet we don't know how to store it, how to keep it through the day and pass it on to the night side. Things are happening very slowly, but these are the areas of investigation to make us a better species, and space activities are doing something about it. Right now, if you notice, in the European subcontinent, around the Mediterranean, between North Africa and Europe, are some fascinating developments in expanding and extending the grid network that is slowly encompassing planet Earth. Now, it is possible to imagine that one day the sunlit world will provide the night and the darkened night side with all the energy that we need, and some important transcontinental lines are being built as we speak between nations that will allow this kind of transfer of energy. And once you do that, I would think many of the other things like nuclear and say nuclear energy may not be part of our stable energy provisions. The United States, as what is called the smart supergrid, which allows us the balancing of power from different parts. Even during the transition during time zones, you will see the balancing of loads happening between different parts of the country. And these kind of technologies are in our future. Now, from the space point of view, for the last 50, 60 years or so, we have thought that, if you go out into space, the sun is shining all the time, and you can harvest that energy and beam it down to places where we really need them. And here you see what's called space-based solar power. I used to be a proponent of it, except that we still don't know how to build very large structures in space and maintain them. Not only maintain them, but also maintain them against the forces of nature, like large effects from solar flares. What would they do to very large structures? Or the constant pummeling of micrometeorites. So, they come 10 times to 100 times the speed of the bullets that we fire on planet Earth, and they impart tremendous amount of kinetic energy on these platforms and can cause great deal of havoc. So we don't know that yet. Of course, nuclear power has always occupied a mainstay, at least since the power of the atom was unleashed during the Manhattan Project. Nuclear power has played a tremendous role, particularly in the developed nations, to provide the energy we need. It continues to provide energy to some of the leading nations of the world. And I just happened to be in Europe, and they were debating how the French energy production, they depend a lot on nuclear energy, is being abused by the European Union. Welcome to the struggle for energy. But nuclear power plants have always been very large. They needed to be large because of many things, including the amount of fuel that was needed, the way nuclear power plants are designed to provide safety in case there's a thing called meltdown, where you have a reactor in trouble. But now people have been taking a hard look at how nuclear fuel and energy production can be made safe, to the point that now there are companies in these great United States of America that is building nuclear reactors that are much, much smaller. And they can provide energy for townships off grid. You've heard the term off-grid places. And NuScale, this is an image from NuScale, which is a company that is already producing nuclear reactors and now slowly going through the regulation hurdles to make them commercially viable. In fact, I was at a meeting a few weeks ago where there were several other nuclear producers who think we may even end up with small townships, like perhaps 6 or 7 or 10 of them in and around Los Angeles, that would probably be using small nuclear power plants to power us. Another big problem that we don't hear much about because we live up here far away and we have oceans separating us. But you will notice that food insecurity is a problem all over the world. And if you look at how it's graded over periods of time, it's gotten better. But I think we should do a lot better if the FAO and the United Nations bring together some fun, wonderful things. And these are things that architects must worry about. Food production has increased and it continues to increase, but we still think there is much to be done in terms of provision. It's one thing to make something, it's another thing to distribute something. As you can see, when there are problems in Ukraine, and they have problems shipping food out to where it's needed. And food networks are at least as important as energy networks. And if you curtail or problems are caused in the supply chain, can have tremendous impact on populations. Now, getting to our world cities, take a look at these maps. In fact, there are several that show you how cities have developed just over the last century, the last 100 years. And many more cities are being developed. For instance, in India, there are about 25 brand new cities. In China, there are probably 150 brand new cities. That is, you start from ground zero and build stuff. And this is to accept new populations in places where perhaps there was nothing before. And as you can tell, many of these red dots are cities you're familiar with. And of course, you see beautiful posters that tell you about where the action is in the big cities. And travel and transport is also part of civilization and global development. Here you're seeing a day's worth of flights between nations, and you will see they emanate from mostly from Europe and the US and transport themselves towards Asia. And this image is dated, which means that if you look at how aircraft are being manufactured in the world today, automobiles are being manufactured in the world today, you will see there's a tendency, a nice a slope towards very large numbers of these vehicles. And this is a very difficult problem to solve because people are growing old. Now, if you walk from Wat Hall across to the west of Watway, you will see a building that houses the gerontology department. And I think we used to have a dean who was interested in aging, and I think he keeps an office in that building. And you will notice that as people grow older, our needs change. And in general, there is an acceptance in the United Nations and elsewhere that the world is growing older. This is happening all across the globe. China, India, Japan, everybody. We are growing old in the sense that we live longer as a species. Our life expectancy is growing. So with all of these thoughts, I have been spending some time with you all in the classroom, talking about what that means to our cities and how do you find, how do you do things to make cities that already exist more livable. And some pictures here that show you what slides we present at various conferences. Every single class, every single seminar that I conduct has a hidden agenda, and that is to promote USC in the matters of the world and to promote our thoughts and ideas in international meetings. And here you see what was told in one of them. Physicists have some interesting thoughts to say about it. Future is difficult to predict. But if you look at the history of architects and architecture, I went to school at USC, sitting perhaps in a room close by there at where you're sitting. And I listened to folks talk about Antonio Sant'Elia and what he thought about how the cities change over time, drawing future cities, The young man went to war and lost his life. In about 1950s, Frank Lloyd Wright was proposing very tall cities going up into the skies. And guess what? Dubai and Riyadh are building incredibly tall buildings. And all these things are happening today, while maybe we are not paying attention to what space activities are doing at the forefront of human exploration and human activities. A space station has been around for more than 2 decades now, and it produces energy just putting out those solar panels into the sun half the day and storing the energy for the other half while it goes around the earth. And the solar arrays produce more than enough energy to keep the laboratories on stations fully functioning. And the 7 crew members who habitate the station. Space station, in case you did not know, has been growing food. It took us a long time for the biologists to tell astronauts that food is important for sustenance. For a long time, NASA did not want any biology on station because it was a physics and physical science station. But now, more and more, they've come to the realization, what good is physics if it is not together with humanities and humans? So we've started to experiment on very clever ways to grow food economically and sustainably. I'll come back to the term sustainable later. We know exactly how to operate what we call the environmental control and life support system to keep humans, to have humans survive and thrive in places enclosed and away from planet Earth. We can use many of these ideas to build better facilities on planet Earth, and we are starting to do that. This is the equipment that NASA uses on board the International Space Station to clean the air, to purify the water. And if you can do those 2 things, clean air and purify water, it is my thoughts and many others of my colleagues, if we can do that for our cities, we would be a million times better off. Water, air, of course, and both of them, to keep the water pure and to keep the air clean, you need energy. So the first part of all the equation is energy. How much energy can you bring to bear? Talking about energy also sustains communication. And here you see what we do on planet Earth to make discussions like what I'm doing with you all now possible. You look at the amount of energy that goes into Google, for instance. It compares with some of the small cities of the world in terms of energy intensity. And we are studying ways to reduce that kind of energy, but right now we are going up the slope upwards for maintaining data and data service centers inside of a Google center. Look at that. That is the cooling pipes needed to keep Google service centers working optimally. And this is also the reason why Google is looking towards building some servers by the seaside or even in the Arctic cold sea water. Look at them. They're expanding all over the world right now. As we say, Google is building 10 or 12 more Google centers around the world. And then we have satellites in orbit that allow you to communicate between these centers. And as you know, Elon Musk here in Southern California has put up thousands of satellites up there, and it's helping communications in a tremendous way. And our own students have ideas on how sub-satellites and blimps can provide data to city centers without the need for going out into orbit or into space. And these things are also happening right now as we speak. Some classes, that I taught, I think this was I was delighted to have your professor, Mark Schiller, in class for our finals. One of the areas of interest for me and for some others in the National Research Council as well is the idea, if we go down deeper into the surface, there are some tremendous benefits in terms of energy conservation and also dealing with surface phenomena that can be rough on humanity. As you can see, deluges, fires, tornadoes, tsunamis can all be avoided if we build structure underground. In fact, under earthquake conditions, underground facilities fare much better. Now, I will ask you that question. Why? I want you to think about it. And these are not new. These are not by any means, they're not new. Architects have known this, and architects have designed this. All you need to do is drive up to Arizona, take a look at Arco Santi by Paulo Soleri, and you'll see that he has been studying underground structures and trying to build compact, high-density building areas which can support between 5 and 10 times the density of populations residing on the surface of planet Earth now. These are some of his works. And so when we look at it, we can beam energy from space or do other things to bring energy. We can have communications from space, and we can build structures below ground, which we are already doing, but we can do it 100 times better using space technologies that allow you to have the environmental control and life support that we already use on space stations. And we are already doing that in some ways, particularly in the East Coast. We have many buildings that are underground. Even if you go to Chicago, you will see a lot of things happening underground, but we can do 1,000 times better. These are some of the interesting infrastructure that goes underground. And we know how to build. We know how to build very large structures. There are tunnels we build every day, many being built now, and very large facilities that are built underground. And this we are thinking of doing on extraterrestrial surfaces too, because we have found that if you go down into what we call lava tubes, you can avoid the harsh environments of space. So this was done in the class. We studied some ideas on how to do that. And, we go into lava tubes and build structures. NASA is very interested in this, so we've been dealing with this. And students here in our class have studied how to make hyper housing in very large communities. And this is why we have skyscrapers all over the world. But we want to think negative Z, going down. And there were some ideas on it in the classroom. And, agriculture can happen above ground and below ground. For below ground, we would use electric lighting. And when you do that, we also avoid anything related with pesticides and pests and pesticides. And these are some of the structures that came out of the classrooms we talked about. Tunnels, large tunnels connecting cities together that can have many different applications. And these are some of the designs that came out of the classroom. And travel. Travel is becoming more and more intense, which means that the intensity of people moving from place to place has increased. And that is why companies spend time buying airplanes. How are we doing in time, Juno? I think, yeah, we're getting close. Good. So these are the things that we are doing, and we think that hypersonic flight is on the horizon. Several companies are competing for very high-speed transportation, including rocket companies that can fly people around the world That is, you fly from a place and get back to the same place in about an hour and a half, which means that in about 45 minutes, you can be on the other side of the globe. So in conclusion, populations are growing, climate change is real, though the word is not out exactly what's the nature, how much of it can be attributed to humans. We know that a transition happened in geological time, which we call the Holocene, to the Anthropocene. That is, humans are contributing without a doubt to changes in weather and the environment. The sun plays a role, we know that. Solar activity can cause havoc on planet Earth. The tree rings show us that during some energetic activities, we can have some difficulties on planet Earth. And all of you need to know about solar cycles so that you know what it does besides create beautiful auroras in the northern and southern poles of planet Earth. And if you talk to the scientists, they will tell you, it's a double-edged question. When there is a lot of carbon dioxide in the air, plants and sea or algae and so on, they love absorb this carbon dioxide. And you may all know that 50% of the oxygen on planet Earth is provided by our oceans. And a lot of it is also provided by what we call the lungs of planet Earth that reside on the land masses in deep forest. So climate change is real. It's happening here in Southern California. Every year, it's grown more intense. And we know that we have fires, and we have other atmospheric effects that are hampering civilization. We know that pollution is a big problem, and travel is growing. So what do we do under these circumstances? So we have to employ all the technologies that we can bring together to solve these problems. Jim Lovelock, who you may all know as the co protege of the Gaia hypothesis. I want you to listen to him on YouTube. His talks are on YouTube. He tells you that the immediate thing that we can do to save our species, because Mother Earth can save herself. She has been around for 4.5 billion years, and other species have survived. But we are worried about our species. And he says the best thing we can do, rather than do some derivative approach on one thing or the other, or put Band-Aid on some enormous amount of activities going on elsewhere, is to become tough. And he says adaptation is the most serious thing we can do. And space technology, human space flight, has some of the tools for us to become a tougher species without messing up planet Earth's fragile biosphere any longer. We've been in the industrial age for over 200 years, and uh, finally we are learning the impacts of the industrial age and the influence on our planet, and we're becoming more sensitive and refined species. So, what can space technology offer? Is actually offering now for the future city. Energy, number one. Solar and nuclear are right now. And then there's geothermal, gravity loading effects. There are many interesting ideas, but the mainstay, I think, for our immediate concerns would be nuclear power. And you may know that the governor in California has kind of postponed the retirement of some of our nuclear facilities. And this will happen in Germany. It's already being discussed in France. And so we have to study how to make these things work better. Fuel cells, let's bring hydrogen and oxygen together to produce energy and splitting them, storing them, and bringing them back together. We already do that for space. And so we can create potable water. Did you know? Did you know that only 2% of water in the city of Los Angeles or in California is recycled? 98% is lost. And if we can ramp that up to 10%, we've already solved for the next 50 years. Think about this. And in agriculture, indoor farming, vertical farms are already changing the way we eat our food. If you go to a gourmet restaurant, some of the food there is grown indoors and locally produced. So this is happening now, and they are free of pests and pesticides. So we don't need so much fertilizers anymore, synthetic fertilizers. Transportation is taking a big turn. Electric transportation is happening right now. And this is also a space-based phenomena. Dwellings, my favorite subject, is about building deeper and deeper underground facilities so that you still maintain the urban visual aesthetic without overcrowding, but still accelerating population density and helping us in many ways. So by going underground, we can have an effect on populations, preserving us from the effects of surface climate change phenomena. And communication advances are happening rapidly. The world is going optical. That's why we lay fiber all over the place. And free space lasers are helping in other ways as well. And artificial intelligence is playing a role in a lot of things where large amounts of data are involved. The Machine Intelligence Research Institute at UC Berkeley, please Google them to see how they're thinking about the ethics of artificial intelligence. In case you're wondering, will artificial intelligence take over? So I have some proposals to close. I'm thinking that if we can get a few faculty together to do a topic studio on something like this, or I could continue my seminar in the spring, I would be delighted to do this. And of course, always, always, always put your work out at international meetings and conferences. It is the first number one thing to get our ideas out into public notice. And finally, I just mentioned this to Professor Juno. Let's make some proposals to Los Angeles. There's always a saying that, think global, act local. I think it is high time, as the new mayor comes in, to put up some new proposals to the city, to LA City, because LA has an underground that is going to waste. Most of it is going to waste. And we think we can do some fantastic local produce underground so that you can eliminate much of the traffic that comes into the flower market and to other places in Los Angeles. And the same with water and power. We are doing some things to recycle. I think the Santa Monica facility is doing something there, and we want to do it at the Hyperion in Torrance here. And these are all proposals we should be sending out to the community. All these goals, many of these goals are talked to and mentioned over the years in the United Nations Sustainable Development Goals. If you're looking at the World Economic Forum, you will see many of these being talked about. If you look at the COP meetings, it is all about these things. Talking about that term sustainability one more time. There is a person and a group out of the Stockholm Resilience Center by the name of Johan Rockström. Since about 10 or 12 years ago, I think maybe 15 years ago was when he first published his paper on what he calls planetary boundaries. How much can planet Earth take of our industrial activities? You will see the gradation over the period of time from pre-industrial to industrial and the current, and you will see the red areas show where we've exceeded the biosphere integrity, the biochemical flows into the surfaces. And some areas we are about to exceed, according to him. And this is a well-known and well-researched area of interest. As to me, when I mean sustainability, and for architects too, and for city planners too, the most important thing cannot be economic sustainability. And it's coming back to us in many, many ways to bite us. We can be economic megapowers, but we will be bankrupt as an environmental species. This is why India, China are all looking towards their surfaces to see how are we polluting. Can we grow the things we need to grow to live? And so environmental sustainability is key to economic sustainability. Give it some thought. And of course, urban sustainability, city sustainability is nested within all of this. Take a look, study planetary boundaries. In fact, we could have a seminar on planetary boundaries. But finally, I come back to the master of it all, Richard Buckminster Fuller, whose books I read in the School of Architecture Library down in the basement below. And he had some very interesting ideas. You know, there are a few among us species who really can articulate how the future is going to unfold. And Buckminster Fuller is one of them, you know, that I've read. And Abe Lincoln is another one. I mean, if you read his Lyceum speech and see what is happening in the world today, they're all very interesting. Take a look at these papers. I have sent them to June and to others. I think Mark Schiller too has a copy. But all of that will be useful. And I also posted some references that we went through in our seminar that is constantly building. And if you look, these are the books that we will be using in our seminar and in the coming ages. The latest one is the chapter that I was invited to write for the ecological design thinking. So if you think I am biased, the reason is because I just completed a chapter in this book on space architecture. There are other books that also point towards a healthy and glorious future for humanity. And in these books too, I believe I may have some contributions. But all these things are for the seminar and for a topic studio that perhaps Juno or Mark Schiller will run, and I would be happy to contribute. Thank you all.
Yeah, thank you, Madhu. Yeah, it is really informative, the presentation. So actually, I joined USC 2012, but I felt some kind of some shameness or guilty because it is my first time to see your really advanced some research work. Yeah.
Okay.
So apologies in terms of that. Okay, so we have some class soon, so I think we can accommodate a couple of questions. So if you have any question, yeah, please ask Professor Thangavelu directly.
I'm happy to engage if
yes.
they have any
Okay,
questions.
so you may see the student up there, okay? Yeah.
Hi, Madhu.
Hello.
When designing underground on Earth or on Mars or wherever, how do you, like, especially for a living, how do you, like, help the psychological part of a, like,
This is a normal question. This is a normal question particularly from us, where we are used to looking out the window and getting a breeze into the room. But more and more, we have conducted some very interesting works from hospital facilities, hospital facilities, um, in areas that we don't have the luxury of open air and open skies. And we have started to get wonderful results. For instance, a few years ago, and I think there may be many continuing experiments now, patients in hospitals constrained by space have virtual windows that show their home environment to them on screen. And they heal better, faster, and enjoy that better than seeing a string of tubes and bags of fluid hanging all around them. And so we are starting to appreciate that better. We do this already in underground facilities where we have virtual vision in very high resolution. I'm not saying that we should all be living underground all the time. There are some studies on how much time people can spend in such remote places. My own thinking is works and factories should go underground where we can contain the effluents better and meter them better rather than just put them out into the air. Jeff Bezos, who we talk to sometimes, mentions that we don't want anything to do with that on Earth. We want to send all the factories out into space. So these are ideas. I hope that gives you some more confidence that we can do something like that.
thank you.
Great. So, okay, so any other questions? So, Madhu, actually, I have one question.
Yes.
So, yeah, sustainability, environmental impact, that kind of stuff. Yeah, I know that as some faculty in MBS, yeah, I'm completely familiar with those things, and also those students affiliated with the MBS. Those people are also very familiar with those topics. So, but for the student in the undergraduate program, so the topic-wise might be a bit high level and then a bit some abstract. So if those, yeah, for the student in the undergraduate program who are interested in sustainability and then global warming issue in an architecture context, what is the best way or easiest way for them to start at the beginning of their career or study?
Oh, this is a difficult question because, to me, at least my exposure to the advanced undergrad student appearing in our classrooms, they have an intuitive understanding because of their own reading, not because of our instruction, because more and more more and more, I am seeing in my classes, in engineering as well, that the more engaged a student comes in with a much better worldview than they did 10 years ago, thanks to openware materials on YouTube, which we used to shun a few years ago. I used to tell my students, you need to really reference your works on Wikipedia. But the policing and the monitoring on Wikipedia has improved so much that that I don't um, force force the pedigree on my students anymore, June. But again, I think we cannot evaluate the entire class in that manner. But some students rise up very quickly, and we can help them. So, here, in answer to your question, it's a case by case, case by case basis.
Okay, great. Okay. One more question from Mark.
I appreciate the fact that you've looked at extraterrestrial habitats, and that was fun since you first did. Was it mid-Earth orbit? The first station that you designed. Anyway, I was wondering why or it might not have been intentional, just didn't have enough room to talk about it. Underwater habitats. That is a different kind of extreme environment, so there are some things that are similar, but it's also another third of the planet that we have not sufficiently addressed.
This is very true. What Mark says, and I have pondered this too. There are a lot of similarities between space and underwater, to the point that NASA has underwater facilities in the East Coast and also at the Marine Biology Facility in Catalina. NASA has interest in doing activities there, training our astronauts underwater. And in terms of why we don't build structures underwater, I think, Mark, you may have given it some thought too, but my thinking is, as a species, we have looked upwards into the open skies and beyond. And this could also be the reason why we don't do very many things underground or underwater. But that may change when the pressures of civilization start to impact us. And if you look at cities today, we have some underwater action going on, but not habitats. I think all of you know Snohera's design for the underwater restaurant that just goes into into the shallow waters. So there are some things happening, but you're right. We could be building things on the ocean or below the ocean. And if you remember, I think it is, isn't it Kikutaki who did the ocean habitats? There are several in the modern architecture books too, about building on the ocean and below it. I have screened some images in earlier seminars, I recall. But over time, we will have to occupy. I know that there are ocean farms we are starting to cultivate underwater, seafood, and that's happening in many nations today. Chile, where our student Mark,
Felipe Hernandez.
that's right, Hernandez, and he's doing some things there. And I noticed that that is a serious area of investigation. Thanks for mentioning that. It should have been in the bullets.
Great. Okay, thank you, Madhu again. Yes, I need to close for the
Okay.
class for students. So yes, yeah, I appreciate all the some information and very well organized presentation. So I hope to see you in person sometime on campus.
Absolutely. I will come by. I'm sorry I did not make it. Now I'm going to run back to the meetings. This week happened. In fact, this last 2 months have been hopping from one conference to the other to the other. And I hope it does not impact my classroom activities in the School of Engineering. So all that is running at the same time. But it's a pleasure to see you, June, Mark, and the students or the audience. Good luck with your work. It is fascinating how quickly a semester ends. It just starts and it's over. And good luck with it all, and enjoy the rest of your semester. Thank you.